Hello children, today we are going to learn about Indian subcontinent's relief features as I discussed earlier in the introduction. So here once again I am repeating, we are going to learn about the location of India with respect to the globe, geological evolutionary background and the major relief division. So first will be the location of India. So let's go ahead with it. So if you see this world map, you will find India is located somewhere amongst the cluster of countries. You see Russia in the north, you see African continent, and you see Australia. So if we go uh, further zooming it in, you will find India is a country which is located somewhere in the northern part of the equator. You see here equator? Yeah, this is equatorial line and it is located along the north of it. And if you see further along the west, you have prime meridian 0 degree, and with respect to this, India is located to the east. So basically, India is found in the north and eastern hemisphere, northeastern hemisphere. So this is the locational aspect of India. And if you see carefully, you will see the Tropic of Cancer. Tropic of Cancer passes through India, almost dividing India into two halves. We will see this a little bit in greater detail in the next coming um, pages. Now, if you see, India is lucky to have two types of climatic regions because of this Tropic of Cancer being passing through it. One we call it as tropical climatic region, and one half of India being within Tropic of Cancer and the Arctic Circle. You see here along the north, yeah, this region we call it as temperate region. So logically, according to the location of latitudinal aspect, India has two type of climatic region, the tropical and the temperate. Now let's go to the next chapter, next page I mean. Here we are seeing the Tropic of Cancer. So Tropic of Cancer divides India into two equal halves. The southern part you have all the Gujarat, half of Madhya Pradesh, Jharkhand, Maharashtra, Orissa, Telangana, Andhra Pradesh, Tamil Nadu, and rest of the southern states. They all fall in the southern region. So principally they are tropical regions. And the northern part is part of Gujarat, Rajasthan, part of Madhya Pradesh, Bihar, Jharkhand, uh, Uttar Pradesh, and all the northern states. They fall along the northern region of Tropic of Cancer. Hence, they have a temperate type of climate. But there are many other factors, as you might have learnt in eighth grade, which determine the climate of a place, not only the latitudinal location. So this is with respect to global location of India and the major latitude. Let's go to the next aspect. India, as I told you, is located in the northeastern part. There is another important aspect of the longitude that we take into consideration is determining the time zone. India lies to the east of prime meridian and it lies between somewhere to a rounded up figure 68-degree east to 97-degree. So this is a long span of longitudinal extent. So in order to have time zone, we cannot have so many time zones extending from 68-degree to 97-degree, almost like 20 degrees, 30 degrees. So it will be very difficult for people to set their watch when they move from east to west or west to east. So to avoid these difficulties, geologists, geographers, they have come to an agreement that we will have a prime meridian for that particular country. That will be somewhere in the middle. So with respect to that, we have consider 82 and half degree, which is almost halfway between 68 and 97 as our timeline. We call it as IST. Indian Standard Time. So this is 82 and half degree. So you have learnt in 8th grade and ninth grade as well that 15 degree makes 1 hour. So 82 and half numerical value I have considered here is longitude. If divided by 15 longitude, it gives you 5.5 hours. So basically this 82 and half degree in terms of time is 5 and half hour ahead of eastern prime meridian, that is Greenwich prime meridian. So whatever time is at Greenwich, we will be 5.5 hours ahead of it. Let's go to the next topic, that is the extent of India in terms of longitude and latitude. Now observe this. We are located north of equator. So the southernmost latitude is 8 degree 4 minutes, we call it north latitude, and 37 degree 6 minutes north latitude. India extends between these two latitudes. And in terms of east uh, longitude, because we lie in eastern hemisphere, so 68 degree 7 minutes to the east and 97 degree 25 minutes to the east. This is the north and south and uh, eastern extent of the India. Now let's go to the geological evolution of our Indian subcontinent. So scientists have come to the agreement that all the continents when the earth was formed were one. Basically, how this could have happened, it's very difficult to perceive for a age uh, of you like student, because you don't have a broader perspective of understanding global phenomena. So let me explain it in this way. So imagine a pan full of milk is boiling. What happens when the boil comes on the surface? There is a flux of cream that turns into bubbles and comes on the surface of the boiling milk and starts getting accumulated in one part of the utensil in which the milk is being boiled. So imagine this is what had happened with the earth. When earth broke away from sun, it was still a ball of fire, and slowly it started cooling down. So the minerals, lighter in terms of weight minerals, they came on the surface and started solidifying. So most of the continent which you find above the ocean, they are made up of those lighter material. So scientists have discovered they are mainly made up of silicon and aluminium. In simple language, we call together as Cl, say Si for silicon, Al for aluminium. So these continents on the surface that appeared together, we call them as Cl. So this landmass, it was one once, but the boiling did not stop here. The internal boiling activity, what we call it at convectional current, which you might have learned in science, the magma kept on and still it's going on boiling. So as a result, it sends convectional currents to the surface. And as a result, the continent couldn't stay one anymore. They started splitting and forming many pieces as a result of the split. So this is how the present continents came into existence. Scientists have discovered that although the surface of the earth appears to be a one solid sheet, but it is actually not. There are many cracks on the surface of the earth. These cracks are very much identifiable on the ocean surface. Why? Because ocean surface are thinner crust than the continental surface. So you will find these divide as I'm showing it in this page on this world map with the dark black line. So these cracks appear all along these black lines. These are called ocean crust and these cracks are called faults the line, and these faults had made the bigger landmass, the original one landmass, divided into many pieces. So scientists have named the mother of all the continents as Pangaea, from which two major landmass first divided. One northern, we call it as Laurential Shield, from where North America, Greenland, Europe, and Russia came into existence, and Gondwana land, the South America, Africa, Antarctica, and Australia came into being, and some part, the Deccan part of India also. So these are the major division. So even now the uh, continents are continuously moving. They are continuously being split along the ocean surface. This study of this movement of continents, we call it as plate tectonic. Plate is nothing but the land mass. This one land mass, which contains some part as continent, some part as ocean floor, together are termed as one plate because they are intact, one piece. But they cannot be predicted as it would remain intact forever. The internal activity of Earth makes them keep on splitting and new lands are being formed. So, as for now, on the surface of the Earth, we have seven major plates. We call it, we have named them, and that has been identified by the geologist as the Pacific Plate. You see, number one, North American Plate. Second is here, North American Plate. Third is South American Plate. Fourth is African Plate. Fifth is Antarctic Plate. And sixth is Indo-Australian Plate. And seventh is Eurasian Plate. Then there are small plates we call Caribbean plates, Nazca Plate, and Philippines plates. So these plates are still in the process of being split. So you will learn more detail about this in your higher classes as you go if you take up geology as your subject. So as a result, now I'm coming to this image. Let's zoom a little bit smaller. So as a result, many continents are formed and they have a peculiar physical features that develop due to their movement. Now, as I told you, the Deccan part of India was part of that original continent called Gondwana land, which split from the mother continent, that's Pangaea. So this southern part of India is made up of that old crust we call basically as Deccan Plateau. Deccan Plateau. So this is made up of that old igneous rock. But when this part split from, if I may be allowed to take this world map, if this subcontinent, the India, split, scientists believe, from the eastern part of Africa and it drifted towards northeastern direction and collided with the Eurasian plate. So let's go back. So when it collided with the Europe, Eurasian plate, or the plate which we call it as Laurential Shield. So this land was intact land, and this land was uh, flat land, and it was having many rivers, and these rivers were depositing some sediment into the sea that is non-existent now. That sea, scientists believe, and they named it as Tethys Sea. So these sediments, which were under the accumulated under the sea Tethys, it was uh, pushed and made to rise when the in Deccan Plateau, the subcontinent of India, the southern part of it, thrusted or pushed towards it. So as a result, the sediment rose from the sea and formed the Great Himalayan Range. So This great Himalayan range, also geologically known as the New Fold Mountain. Why do we call it as New Fold Mountain? Because it is made up of new material that is brought from the sea. And why do we call it as Fold Mountain? Because when the sediments are compressed by a hard uh, rock material like the Deccan Plateau, they are thrusted upward, and from sea bed they rise above and come in contact with the atmosphere and they solidify. So this thrust is not one time push, it's a constant activity. So continuously the Deccan Plateau is pushing towards north. So as a result, we have ranges of uh, Himalayan mountains. In another word, if I would be allowed to say it in simple, it's like a fold of cloth. You crush, try to bring the cloth together by both the hand crushing them towards each other, you will find that folds are formed. So they are formed in like parallel layers. So in the same way, the mountain ranges of Himalayas are also formed in parallel ranges, and they are folded because the layers, the sediments which were stretched out when compressed, they rise and make folds like the wave of a water. So these fold mountains are called the Great Himalayan Range of Mountains. They are formed as a result of compression of Deccan Plateau uh, with the Laurentian Shield in the north. Now, how this happens over a surface of the earth? So, if you see a little bigger picture, if I may try to zoom in, this is how the land looks like. Some of the land they are under the ocean, and some of the land they are above the water bodies. So above the water bodies we call them as continent, and under the water we call them as ocean floor. So these ocean floor, because they are thin in thickness, that's why it's very easy for tectonic movement or the convectional current or the boiling magma to hit and break through and come on the surface. But we are not able to identify any of these features because on the surface of the ocean nobody lives, and we cannot have any means to track them all the time. So under the water or over the surface of the ocean crust, so many activities are happening every day. We seldom come to know. Only when these activities are closer to the continent on which we live, and we have various instruments to measure all kinds of activity, we are not able to identify. So on the continent, if any slightest movement occur, they are captured by seismic measuring instrument in the seismological labs that we call it as earthquake and etc. So along the ocean floor, when the convectional current try to move up, it breaks the crust and the magma comes on the surface and solidifies. So as a result, new landforms are formed. That's why we call it as divergent plate. Here, new lands are formed, divergent. Also, we call it as constructive zone because new lands are being constructed. On the other hand, for the same plate, if we go to the region where this ocean crust is meeting the land crust, the crust, as a result of push factor from the convectional current, tend to move towards the continental crust. Because it's heavy, it cannot override the continent, it slides down. On the other hand, the land, the crustal continent, the continental crust crushes and moves over the ocean crust. So as a result, whatever sediments are found along the ocean border, along the beach. They are compressed and they are made to rise because they are found along the ocean border. So these mountain ranges which rise from the ocean bed do form a range of mountains. They are new mountains. They are made up of sedimentary rock and they are folded because the push is continuously coming from the ocean floor in a with an interval of break sometime, because the convectional current, they come, they break, they calm down, again they push, break, and then again they calm down. So we have range of mountains. So this is about how along the ocean and along the continental border the seismic activity takes place. Another example to bring you a closer uh, identification of how this happens. You see ocean crust over here. When they move, they are being heavy, move to down back to the mantle and the core of the earth. They again melt down. On the other hand, the landmass, the continental crust, they slide over, and the sediment along the ocean or beach, I should say, in a simple word, that sediment rises to form the mountains because it happens in an interval of time with the each push. So each push gives the rise of a range of mountain, a calm, and then again the push comes and again the sediment rises. So usually the ocean and the land crust, the ocean and the land crust where they meet, that is the point where you have the deepest part of the ocean. So this deepest part of the ocean we call it as trench. This is the deepest part. So along the uh, continent where you have the fold mountain, you in the ocean floor you will find even the deepest part of the ocean. We call it as trench. So let's go to the next. So this has resulted in formation of Himalaya, and if you see clearly, you have ranges of mountain and all the ranges are moving parallel to each other. They are parallel to each other. So this is the result of the regular intervalled pushes from the hard continent to the softer sediment and their rise and formation of fold mountains. So with this, we finish the geological evolution of India. Let's come to our Indian relief features. So first topic is the Himalayas. So as we are discussing about the Himalayan formation, you have learned that Himalaya was formed as a result of uh, southern Deccan continent, uh, which was a piece of African subcontinent, broke from Africa and drifted toward northeast and pushed the Eurasian shield, Europe and Asian, Russian shield uh, together. They were named as Laurentian shield. So, because the thrust was in such a manner that it resulted somewhere in formation of crescent type of sedimentary rock upliftment. Crescent means like a half a moon. So you will see the parallel ranges of Himalayan mountain forming as crescent. And in between somewhere you will have a nodule point from where the ranges begin. So here we have the Hindu Kush mountain going further west, and Karakoram range and Zaskar range and Pir Panjal range coming out from this moving towards east. So in terms of only Himalaya, we have three ranges in terms of their height. The highest is Greater Himalaya, which is almost in the middle, and then you have towards south, towards north, you have Zaskar and Ladakh range, And towards south, you have Pir Panjal, Dhauldar range, and Shivalik range. These are the lower ranges. So most of this greater Himalayan range, they remain covered with ice because of altitude. They are quite height, over 8,000 meters above sea level.